Good afternoon, everyone. Thank you for joining us. My name is Jason Geagan. I am the Vice President of Commercial Sales for RM Manifold Group. For those that have not joined us before, first off, thanks for joining us today and welcome. If you're not familiar with the Zoom interface, there are two buttons that are going to be very useful to you throughout the presentation. One is the chat window. That's for technical issues if you can't hear, if you can't see the screens, whatever it may be. And then the Q&A button is a great option if you have any questions. Obviously, you can take notes and write that down and wait till the end, or you can just pop that on. And if it makes sense to break in, we'll do it during the presentation, or we will come back at the end and answer any open questions at that point. So to introduce who we are and what we do, so RM Manifold Group is a draft control manufacturer out of Fort Worth, Texas. We go to market under three different brands. US Draft Co. focuses primarily in the mechanical space for boilers, water heaters, pool heaters, any fuel-fired appliance. We do fans, dampers, controls, sensors, makeup air, combustion air systems. If you joined us last month, you learned a little bit about that. KW USA is a partnership with a German manufacturer, Kutzner and Weber. They focus primarily for residential fireplaces, residential and commercial pizza ovens, coffee roasters, brew kettles, very kind of some specialty products that deal with draft equipment, so fans, dampers, controls, etc. And then today we're going to talk about LF Systems. LF Systems really focuses on three areas. One is commercial laundry. So if you're doing hotels, hospitals, laundromats, dorm room or dormitories with a bank of dryers, we can work on common vent systems for that. Fans, sensors, lint collectors. We also get into sterile pressurization controls. Again, that presentation was just a couple months back. If you're interested in that, touch base with me and we can get you a copy of that presentation. But today we're going to focus on high-rise exhaust. And when we talk about high-rise exhaust, we're talking about three primary areas. One being bathroom exhaust, kitchen exhaust, and then finally laundry exhaust. So these are individual exhaust systems that are being ducted into a common shaft. And we'll talk about that. We're going to primarily focus on the laundry exhaust, but many of the things that we discuss will apply to both bathroom and kitchen. And to understand what the difference between on the dryers is, so type 2 dryers, these are, again, those public dryers more for commercial laundromats, laundry rooms. They can be in high-rise exhaust systems where you're having a laundry room on each floor. They do have slightly different requirements as far as exhaust pressures and length of run. What we're going to focus on is the type 1 dryer. These are domestic individual dryers in the space themselves. Maximum length where you can on a type 1 dryer is 35 feet according to the IMC, or 14 feet with 2 elbows according to the UMC. Basically, an elbow equates to about 5 feet in that equation. So depending on which code you follow, you have to kind of look at that. The other option is to follow the manufacturer's instructions. So if you have a residential dryer that says that you can go beyond that 35 feet, you can do that. However, keep in mind that dryer might be replaced down the line with a dryer that is not capable of handling that. When you're looking at type 1 dryers, the back pressure, the positive outlet pressure, is typically between 1/10 of an inch and 9/10 of an inch. And when we look at this, that's kind of where this curve comes in, is basically a traditional 200 CFM or 180 CFM residential dryer. That number comes from a no back pressure, no pipe attached. So the longer that pipe, or if you add clothing to it, you start to extend or start to limit the length that dryer can handle. And the difference between, say, a boiler, where if you extend the vent, it doesn't operate, the dryer will still operate, it just won't dry. And so that's why you may have, even in your own home, a dryer that might take longer than one cycle to dry jeans and towels, something very heavy. So you might want to measure out your dryer exhaust. I know I did that when I first started doing this, and I'm about 42 feet. So I've exceeded that 35 feet, and unfortunately the builder is long gone. So we'll continue on. That 35 feet, actually, reading into the code, again, 35 feet is in IMC 504. Deduct 5 feet for every bend. The exception being that a dryer manufacturer does give you the exception. And then same thing for UMC. These are just to kind of show you where in the code it is. So you're looking at 504. So as we get into multi-story exhaust, there's a few ways of doing this when you're doing dryers and hoods and bathrooms. One way that we're not going to discuss because it looks really silly, but it is in someone's installation manual, is to have individual dryer runs going either up through the building or down through the building to an exit point. We're going to avoid that one, mostly because it's hard to get to that 35 feet and stay within that perimeter there. So the other one we're going to look at is individual sidewall. And beyond there's a few issues with this. One being aesthetics. As you can see the picture on the right, there's a brand new, fairly new building. And they just have all of these hoods, these dryer hoods and bathroom hoods, kitchen hoods, all coming out the side of the building. So aesthetically is not something that is very attractive. Secondly, is if they put them in this scenario over a balcony, now you can have dryer exhaust or kitchen exhaust dumping onto a balcony while you're sitting out there enjoying your evening. And that's all of those are kind of things that you can get over. But the one thing you can't get by is a study, AIA basically says that you should minimize the penetrations in the sidewall of your building because that just creates more areas of leakage into your space. Also, Cornell University did a study and found that a 7-mile-an-hour wind can create almost 9/10 of an inch back pressure on the exhaust. Well, if you remember back a few slides, the maximum amount of back pressure that a residential dryer can handle is about 9/10 of an inch. So even if you have that dryer up against the exterior wall and you go straight out the sidewall, you're still going to have potential issues because of that windward wall. So one other issue that you have with this is location of your dryers and your kitchens and your baths, and in this layout, your bathroom and your dryer are both near the center of the building, furthest away from that exterior wall, right? So this length may or may not stay within that 35 feet. Okay, the second one, it's even worse. It's all in that, again, in the center of this condo, to where your kitchen, your bathroom, and your washer and dryer all have to go throughout the entire apartment or condo to get to that outside wall. And the reason they do that is because all of your utilities are typically in the center of the building. So your gas lines, your electrical, all that's coming up through the center of the building, much easier to access on the interior of the space. And plus they want to save that exterior wall space, balcony, glass for bedrooms and living rooms, which makes sense for the view, right? So the other option that we can look at and we recommend is our high-rise exhaust system. This is a central shaft-based system. So instead of running those dryers, those hoods, the bathroom exhausts out through the sidewall individually, you'll now actually run them to a vertical chase that's running up through the building, picking up 1 or 2 dryers per floor or 1 or 2 kitchen hoods per floor, and running it up to a vertical termination. Now there's some code things you have to look at. And again, we're going to focus on the dryer codes, but a lot of these will apply to your kitchen and your bath. The shaft and the duct must be installed and constructed in a fire resistant rated in accordance with the IBC. Dampers shall be prohibited in dryer exhaust. So I mentioned this in my commercial presentation. You cannot have any impediment between the dryer and the termination. Dampers, fire dampers in that duct become lint collectors. Lint catches on fire and fire is bad. Okay, so we can't have any dampers in the airstream. We'll tell you how to get around that when penetrating that fire rated shaft. The ductwork within the shaft cannot have any offsets. You cannot come up through a building, say 4 floors, and then have an offset and continue that shaft, picking up more dryers. The exception, and this is where it kind of gets into some gray area, but once you pick up that last dryer, it is no longer a shaft or a vertical ductwork, you can offset at the roof to then go to your fan. So basically, you just can't have any offsets between your dryers or your hoods. The fan motor must be outside the airstream, and it must run continuously on standby power. And I've had a few projects where this was a hang-up because they didn't have a generator for a 5-story building. They didn't have a backup generator on site. But we did look at some alternatives, battery backups, or some kind of a continuous power source available to that. A few other things to keep a look at. The fan must be monitored where you have an audible or visible alarm. So it has to be connected to something that notifies you if the fan is not operating. Makeup air shall be provided for any exhaust system in a building. So you gotta make sure that if you're sizing that fan for a vertical shaft, you must provide makeup air. Clean out at the base. So you should have an access door or some kind of a clean out at the base of the shaft. So any lint that does fall from the shaft can be collected and cleaned out. Again, screens should not be installed in this termination. It goes back to the damper discussion where it can collect lint. And a common multi-story duct can only serve dryers. You cannot put your dryers in your kitchens or your dryers in your bathrooms in the same exhaust shaft. Okay, so now we've kind of talked about why you want to do a shaft system versus a sidewall, but now we're going to learn about why you would want to go with a constant volume or a variable volume versus a constant volume. So there's really two ways of doing this. You can just put a fan on the roof, turn it on, set it for whatever speed it needs to be, and just let it run until it dies or until something happens. But basically the problem with that is this fan is now running, in this example, 1600 CFM, the entire length of the shaft. And if it's 2 in the morning and no one's doing laundry, that air has to come from somewhere. So it will draw through these openings a little, but really where most of that, you have to have some kind of a relief damper or an offload damper so that you're pulling in that 1600 CFM to make sure that you don't draw this into a vacuum. So what ends up typically happening is this duct is actually, excuse me, this duct is in a conditioned space. So now you're drawing conditioned air right up that duct, all the way up and out through the building. And in this scenario, it's 1600 CFM. It's a lot of air, especially in those slower times where you may not need the full 1600. So what we do, we'll still size that fan for 1600 CFM, but instead of having it run continuous at a constant speed, we're going to put a pressure controller with a sensor. What that sensor is going to do is just maintain, or that controller is just going to maintain a very slight negative throughout this shaft. Okay, so as dryers turn on, the pressure is going to build up, that fan is going to ramp up. As dryers turn off or as kitchen hoods are shut down, that fan is going to ramp back down. So when it's running, or in peak capacity mode, it may be running at 80–90%, but during the middle of the night, when no one's using the dryers, no one's using their bathrooms, that fan's going to ramp down to its lowest speed, typically 10 to 15% of its capacity, and just sit there at minimum speed. And so we're maintaining that code requirement of constant flow, but we're not having to deal with constant speed. So we're not wasting all of that air being pulled up through that shaft. Okay, so now we won't even need that offload duct. So now it's just getting a little bit of air from each space to maintain that minimum CFM. And that's where we offer our high-rise exhaust system. So the high-rise exhaust maintains a constant pressure, uses our existing technology. And again, if you've joined us for any of our presentations, you've learned about the EC flow technology with our positive and negative control systems. We use basically the same base program for all of our controls, and then we specialize and we customize them for the application. For this instance, we use our L150 control. We'll talk about that here in a second. Maintain a slight negative here at the base, and then we'll have a fan up here on the roof. Again, just kind of varying the speed throughout that. The DEF, this is a perfect fan for this application. Does have removable access for clean out. So if there is any lint built up in the fan, we can open that panel, access it to clean that out. It's a 90-degree construction, so it can be installed either on equipment rails with an inlet on the side, or it can be just mounted right on top of a curb, and then have the discharge off to the side with a gooseneck termination. Up to 7,500 CFM. We do have our UL 378 and 705 listings, which are required for this application. It can be installed out indoors or out, so this is no problem going up on a roof. And it does have an aluminum impeller and mounting block, which meets the Type B spark resistant requirements. All of our fans from RM Manifold from US Draft and LF Systems offer EC motors up to 1 horse. So now we have a direct speed control from the controller directly to the motor, allows us to turn down to about 15% of capacity. It's a very high efficient motor. Anything above that, if we start getting above about 2,500 CFM, we go to our 3-phase induction motors. And these are standard off the shelf, normal frame motors. There's nothing custom or special about these. But these actually give us a 10-to-1 turn down. So we'll turn down to about 6 hertz. And we can do either 230 or 460. Also, if you're in Canada, we do offer 575 volt 3-phase as an option. Nice thing is when you buy this package from us, we do supply the VFD, so it's pre-programmed straight out of the factory to run with our control package. That controller is our L150 I mentioned earlier. Has the same EC flow technology as all our other controls. It is a true bi-directional controller with transducer, so we can read positive and negative across 0. Offers a high and low pressure safety function. It is field programmable, although most of the settings are going to be preset from the factory. There are adjustments that can be made if your sensor location isn't optimal, or if it's a shorter building or a taller building, we can adjust the PID loop accordingly. And Modbus is standard if you have a backnet, or if you have a BMS system. Yes, we can use backnet through a gateway, but that way you can see the status of all your fans and all your shafts on your BMS. And go back to the pressure thing real quick. So the reason why we bring that up is a lot of controls that are out there only read negative pressure. So they read from 0 to 0.6. And the problem with that is that if your set point on a shaft, you want to maintain as close to neutral, or it's a very, very slight negative. You don't need to have a deep negative coming through that entire shaft. So if you set that for a 1/10 of an inch or 1/4 of an inch, to get you back into that middle, you're going to be pulling a lot of excess air out. The whole purpose of having a variable speed system is to minimize that excess air being drawn through. So we want to get it as close to 0 as possible. So again, maybe a 0.02, a 0.05, somewhere in that range, and just keep a very, very slight negative in the system. And that's why with ours, having that range on both sides really helps with that. Because again, if we set it here and the system dryers start to operate and the pressure starts to build, we actually can sense that pressure change and get us back to set point. With a negative only, if we start to climb above neutral, the controller actually doesn't see it. It's kind of like pegging a speedometer back in the day, where you just don't know how positive that system is, right? Which is why they set the controller for a deeper negative, so they have that range to respond to. But again, we've always been a bi-directional controls from our launch 12 years ago, and so we've always believed in true bi-directional control systems. A few years back, we started getting requests for combining shafts, and what I mean by that is taking, especially on bathroom exhaust, where you're running 50 to 60 CFM per bathroom, and there's maybe 6 or 8 floors to that building. You're only talking 400 to 800 CFM if you double it up. There's just a lot of really small fans up on the top of the roof. So what we started looking at code of how you can use the basically combine shafts into a single fan. And the only issue that caused for us is, well, how do we control that in a variable speed system? So we introduced the L330. What we do now is we take replace the L150 with this L330, and we put 3 sensors, 1 in each shaft. And basically, we can look at the highest, the lowest, or the average of the 3 sensors and modulate the fan accordingly. So now, instead of having 3 small fans, we now have 1 larger fan. And again, we size this based on the operation of the building and your recommendations based on how the building intends to operate. And we select the proper fan and then select the L330 to modulate 1 fan on 3 shafts. Lowers the cost, the install cost, and also lowers operational costs because, again, you're not having to maintain 3 products versus that 1. Has all the same features, true bidirectional, high-low safety, Modbus or BACnet. Nice thing is it does come with a 7-inch touchscreen, so now all of that information is now on a beautiful interface that the operator or the building engineer can take a look at whenever they need to. When it comes to shafts, we talked about how you cannot have dampers in a dryer exhaust system, but if you look at the IBC, any duct that's penetrated, any fire rated duct that's penetrated must have a fire smoke damper. So how do you get around that? Well, the exceptions to the fire and smoke damper is a exhaust subduct extending 22 inches vertical into the shaft. So we call it the subduct method. So instead of having a fire smoke damper on the inlet of that shaft, we'll put a steel subduct into the shaft and extend that 22 inches. And so a lot of guys, a lot of installers will make their own. They'll basically take 4-inch or 6-inch pipe, cut a hole, fire caulk it, and then put a 90 and run a piece of 22-inch pipe. And it works. That works fine. The problem with it is it does take up a lot of space. When you're sizing up your shafts, you do have to take that out of your equation as free area because it's now taking up a lot of space. And so what we introduced several years ago now, what we call our low profile subduct. It's actually a round rectangle transition piece. So this would be a 4-inch inlet. And then it just makes it into a 2.5 by 7-inch rectangle. Gives the same open free area as the 4-inch pipe, but now it's a much cleaner, much smoother transition in the duct, and it provides a lot more open space in the middle of that shaft. So we can actually save up to 52% of free area in your shaft using the low profile subducts versus a field fabricated subduct. And there's just a couple of pictures for you, as well as a diagram of how that operates. Again, comes in 4-inch, 6-inch, or 8-inch. We can also make 10s and 12s for customs. That's a pretty big, inlet size, but we can do it. But it now allows a much simpler installation, much more cost-effective install. I've had several sheet metal contractors that originally claimed that they could build these on their own for cheaper, and then they tried, and then they realized they couldn't, so they started ordering from us. So it's a great option for field fabricated shafts using the subduct method. Now, keep in mind, this can be used for kitchens and bath as well. It's not limited to just dryers. That is the purpose of it, because you can't do the dampers. But the upside using it on bathrooms and kitchens is less maintenance, less issues with maintaining, inspections, power, all of that good stuff. So this eliminates all of that. You don't have to have access panels in your bathroom. You don't have to in your ceiling. So it really allows a lot more flexibility in your design using the subduct method. So looking at field fabricated systems, a field fabricated shaft, it's a great option for some buildings, but there are some concerns about building a field fabricated shaft system, even using our low profile subducts. One of those is the time that it takes. There's a lot of time. It takes a lot of time to build a field fabricated shaft system. It's also involves a lot of, a couple different hands, but because you have to have your shaft or your actual ductwork, and then you have to have your GC or your carpenter do double sheetrock, wall stud support, another layer of sheetrock. And so it takes a lot of space. You have to have multiple inspections. There's really no warranty other than, just whatever the contractor's warranty is, typically, 366. There's no consistency. There can be some differences between one project and the other, or one day to the next, depending on which, fabricator is out there that day. And, there's some great fabricators out there, but people just have an off day, and it happens. So what we recommend is called our prefabricated shaft system. This is a round shaft with integral subducts as an option. So we go 8-inch to 36-inch round with 4, 6, or 8-inch taps. Inner wall is 20-inch galvanized or 20-inch aluminized steel with a 1/2-inch flange. And the outer wall is 24 gauge. We provide a 3-inch insulation blanket straight from the factory. So it is prepackaged, wrapped from the factory, and it is a UL listed to ISO 6944 for the 2-hour fighting. So this is now not only your ductwork, but it's also the shaft itself. And it doesn't even require a finish wall, though most people do box it in for to drywall, single drywall. And this is ideal for everything we've talked about so far. So now, instead of having to worry about making sure that that subduct is 22 inches, making sure that the ductwork inside is smooth and free and clear. Basically, you send this out to apprentices with a screwdriver and a caulk gun, and they can install it fairly quickly. It's a standard 1/2-inch flange, so many installers are familiar with that method of installation. It has a lot of benefits. One of being is the space. So a standard 24-inch square shaft is going to actually require 36 by 36 inches of available space, because you basically have 1 inch worth of sheetrock, 4-inch gap for the studs, and another 1 inch of sheetrock on both sides. So now you're gaining 6 inches on both sides. With us, because we're only 3 inches, that 24 by 24-inch round pipe, 3-inch is only 30 by 30. Now, the first thing people say, well, 24-inch round is not the same as 24 by 24. That is true. However, what we've found is that the actual flow characteristics of a vertical shaft, the corners play very little role in the amount of flow that's available in that shaft. So typically, we will just kind of round those off anyways. So a 24 round can, in most cases, handle the same capacity as a 24-inch square. So we're going to save you about 6 inches per shaft in both left to right, as well as top to bottom. Now, 6 inches doesn't sound like a lot. However, if you work in New York, if you work in Chicago, if you work in Miami, where price per square foot is 4 to 5 figures, 6 inches is a lot. Okay, so you can add a little bit more space in a closet. You can add that extra, few inches to a walkway, whatever it may be. So just something to keep in mind for that. The other thing is single point of single source of responsibility, which means one trade that's going to install it, one inspection for the entire thing, 0 clearance to combustibles. You don't have to have this. We had a project where they actually just wrapped it with a decorative wrap and made it look like a Roman column in their hallways. So it doesn't even have to be put behind a wall if you don't want it to be. Most times they do. Don't get me wrong, but it provides a lot more kind of consistency, because it is a UL listed product from a factory. It does have a limited lifetime warranty. We give you full technical and engineering support on the system design. So it really eliminates a lot of questions when it comes to designing and installing vertical shafts. One other component that we do want to talk about is constant flow dampers, or constant volume dampers, excuse me. This is a great option for bathrooms. Instead of using an individual fan, use constant volume dampers. Set the set screw to the flow rate that you want, and then it's just a spring rated or spring damper blade that will adjust based on the flow that's needed. So again, it's a great option just to kind of drop the cost on your bathroom exhaust. Now that does require a constant flow system, constant volume system. So we cannot, at that point, if we're going with the RDR, we are not going to have a modulating system, though we can, with our fan and our controls, still meet all the other code requirements and adjust that speed much quicker than if you were to do it with a with a balancing standard balancing system. So the other thing we look at when sizing our high-rise exhaust is diversity. So depending on the number of dryers or hoods per floor, depending on how many per shaft, I should say, we will determine that, hey, in most cases, if you have 20 dryers going into a single shaft, the chances of more than 10 of those working at once are pretty slim. And the other thing, especially with dryers, is that that 180 or 200 CFM is the maximum CFM that's being drawn through that dryer. When the dryer first starts up and clothes are really wet, it's a lot of resistance in the dryer, so you're not actually pulling as much air at the beginning of the cycle versus at the end of the cycle. So a lot of that can be taken into account when it comes to sizing your shaft. So we can size the shaft for a 50% diversity and then give you a little bit extra capacity in the off chance that it goes above that, to make sure that we maintain that pressure in the shaft. And with that, we kind of wrap it up. We do have a couple of questions that have come in. If you have any questions, the Q&A button is a great option, or the chat window. One that came in was, during a power loss building, we'll have no power except for life safety equipment, toilet exhaust or kitchen exhaust are normally not on emergency power. Why does the dryer need to be on emergency power? So this is actually has less to do with the dryers or kitchens. Any vertical shaft that's serving more than one space, it's actually for smoke control at that point. It has to do with if apartment A is where the fire is located. If that shaft fan was not on emergency power, it actually would not draw the smoke out. It could potentially draw into another. And I can see if I can pull up where it states that in code. Yeah, so that'd be 504.10. This is for dryers. Again, there's a similar comment on. Look for it real quick. Yeah, there we go. Number 7. So 504.10 does require it. And it has to do with the controlling of smoke in a fire event. Because if this apartment were to be on fire, yes, the subduct method should prevent most of that. But what they want that fan to actually become a draw point to get it out rather than just lingering in that shaft. So that's the primary reason that I've been told with regards to that code. And there again, that's not exclusive to dryers. That's on any vertical shaft system. So any vertical shaft with a fan should be on continuous power for that purpose. So hopefully that answers that question. Another one, can you provide the factory fabricated PSS and just single wall duct and integrated? Yes. So yes, that's a great question. If you are already planning on a shaft and you don't want to do the double wall, so you can use a single version. It's not UL listed, but it does have the prefabricated subducts built into it, the integrated subducts, and it's the same flange. It's actually really easy to install at that point, because now it's just the flange and stacking it on top of each other. With the double wall, there is a small piece where you have to wrap that connection. But yes, it is available in single wall. We've also used that. There are other uses for it. Obviously, we're focused on the high-rise exhaust, but with our stairwell pressurization, that typically is going to be in a fire-rated shaft. We've used it in the flip to where it's no longer an exhaust pipe; it's an intake shaft. We don't, and that one obviously doesn't have the subducts, but it does still have the tap, so we can have the fire rated duct prefabricated, so you're not having to wrap that or deal with that. So great question. Any other questions that I did not answer? Okay. Well, I'll stick around for a few more minutes. And if there's any questions or if you have any, projects that you're working on, obviously you can go to lfsystems.net. That is our website. There's a how to buy button. Top right corner shows you who your local rep is. We also have some, data sheets, brochures, etc. The other thing is any design requirements or any design requests, send it to our engineers, our application engineers, rmengineering@rmmanifold.com. So again, thanks for joining me today. And like I said, I'll stick around for another minute or so in case there are other questions. Otherwise, have a great rest of your week, and we'll talk to you guys soon.